Have you ever gotten into a hobby and gone so far down the rabbit hole that you kind of forgot what started it all? Well, that's what happened to me. My wife was given a bunch of her family's old 8mm film and asked if we could digitize it. So one thing led to the next. I basically bought this Kodak reel scanner and started digitizing everything. That led to wanting to get into film photography, developing, and then motion picture filming and home developing that, which eventually led to me wanting to build a better scanner. So I did that. And this is it. This is the T-Scann 8, designed by Torolf. I'll link his website down in the description. But it's a DIY frame-by-frame scanner for 8mm and Super 8mm film. It uses 3D printed parts, a Raspberry Pi, an Arduino Nano, custom-made PCB board, metal top plate, and an enclosure, and then all of your basic small electronic parts, transistors, resistors, capacitors. It does use 3 stepper motors as well. But yeah, this is kind of just a quick slideshow of my build. I don't have a lot of experience with electronics besides building some guitar pedals. So this was kind of my first jump into a bigger project, including using a Raspberry Pi and an Arduino Nano, which I've never used before. So to build this, it's DIY, so you have to have some knowledge of soldering, using a multimeter, some 3D printing, maybe some basic woodworking. I went a little bit more advanced than normal on that aspect since that's another hobby of mine. You do have to have some computer skills as well, installing an operating system onto the Raspberry Pi, using the command line interface for installing Python and other things like that. You don't have to code. I'm sure having a basic understanding of Python would help with some troubleshooting, but I have a very basic knowledge of Python and coding, and I was able to do everything. So it would only help the more you know, obviously, but for the most part, if you're a beginner like me, I think it's totally doable, especially nowadays with YouTube and Google. So you could just buy a Kodak or Wolverine, but if you want higher quality and more control over your images, this would be probably the next best route, except for obviously sending it out to professional labs and scanners. But I'm a DIYer, so I wanted to do this myself along with home processing my own Super 8 film in my darkroom. So yeah, let's take a look at the inside. I'm going to keep this kind of basic because I'm not an expert at electronics, but you can see here I just have kind of like picture frame hinge thingies to keep the bottom closed. But you open it up and here's everything. So it's got 3 NEMA 17 stepper motors, the custom-made PCB board right there on the left, and then kind of to the right is the Raspberry Pi as well. You don't really need to go in here a lot once you got everything connected, but I do still kind of want to mount some sort of hinge to keep it up like a car hood. But yeah, so I'm going to kind of run through a couple of the things that you'd also need to get. So besides the custom-made PCB board, which is on the designer's website, you also need a Arduino Nano. Don't make the mistake that I made and buy and install an Arduino Nano 33 IoT. Apparently that's different. It uses different voltage. So that was a fun lesson to learn. Got a lot of practice desoldering. And then here's the Raspberry Pi. It's a Raspberry Pi 4. With nothing really extra besides the camera, which I forgot to mention earlier. The camera is a Raspberry Pi HQ camera, C-mount with a microscope lens. And then that right there is the power converter, so it takes the 12 volts, turns it into 5.1 volts that you need to adjust, and there is still a 12 volt lead that comes off for the LED that shines to the camera or through the film. But yeah, kind of an overview of it. All the components are on the website. Like I said, I ordered pretty much everything from Mouser. Even had to reorder some stuff after I messed up with the Arduino. But hey, that's how you learn things, is by making mistakes. So here's kind of how it works. You load it up on the left side. You want to make sure the perforations are facing upwards, because basically what's going to happen here is it's going to work through a couple rollers and then go to the film gate. Before the film gate, there is a UV LED that travels through the perforation and then to a photo transistor. That photo transistor basically detects the perforation edge, and then through the software, it will communicate back saying, hey, I detected an edge. It should be aligned based on the software, and take a picture. And then travels through kind of where I'm feeding it right now, the capstan. And then this right here is a modification with a pinch roller. This just helps get it to travel smoother, essentially. And then it'll wrap around into this traction switch. And that was pretty neat. That basically detects the traction and then will tell the third motor, the take-up spool, to then turn to keep tension. So basically they all work around. You can see there you want to go clockwise. Make sure to start it off and kind of feed everything through and then take it up. You want to be kind of close to where the film starts, so that way you can start focusing the camera and everything. So again, here's kind of the path of travel, and then the camera and the light work together. The light is a 12-volt light, so there is a step-down converter that you have to wire and install because the Raspberry Pi and Arduino are 5.1 volts versus the light, which is 12 volts. So here it is running. You can kind of hear how loud it is. It's not really loud at all, but obviously makes some noise. Here it goes through the traction stop. Again, I think that's pretty neat how it detects that. It's basically, I think, a micro switch that I just made based off the design. It uses foil and a couple screws. So again, not my design, but I think that's essentially what a micro switch is. There's the capstan and the pinch roller traveling. Yeah, so, and then right here you can see there's the UV LED light shining through the film perforation to the photo transistor, telling it to move a frame, essentially, based on whether it's regular 8mm or super 8mm. One more thing, I use these Wilson racquetball grips on the capstan and pinch roller just to kind of help move the film along. You can use it at the beginning too for cleaning. I haven't used that yet. I use these lint-free gloves with some 3D printed 8mm film rollers to clean before scanning, because old film is disgusting. Every single person smoked in the 1950s. Everybody, like even doctors, everyone smoked. So it's covered in that gross yellow stuff.
What cigarette do you smoke, Doctor? Once again, the brand named most was Camel. Yes, according to this repeated nationwide survey, more doctors smoke Camels than any other cigarette.
So here we're going to get into the actual software. So I'm actually using what's called T-Scann. It's an alternate to T-Scann, which the original designer programmed. T-Scann is kind of a fork off of that. Just has a different UI. I think it has a lot more features. I honestly didn't even try T-Scann after kind of seeing this, and I just liked a lot of the features that it had. So I went straight for it. So the one thing right off the bat that I'm experimenting with, just to kind of keep my comparison between the Kodak Reels scanner fair, is the auto exposure and auto white balance with this. It's massively different. I think it's fair to compare the two, since the Kodak Reels has an auto white balance and auto exposure, which I hate. But for some reason I really like it with this one because it actually works better. In the future, I'm going to obviously turn that off and maybe go scene by scene for auto white balance. But the cool thing is this is frame by frame, so you can literally edit each scene just based on each individual photos. So here I'm showing the difference between Super 8 and regular 8. If you don't know, the perforations are different. So this program, you have to pick which film you have. And then you have your resolution. It can shoot up to 4K. It can also shoot DNG, so kind of raw, at least from my understanding, but I'm keeping things simple and just going JPEG. Change your output format or output device. I'm using just a 16 gigabyte flash drive. Yeah, and then you focus your camera, which I kind of already did earlier. You basically just move the camera forward while seeing a live view until you get into focus. This is the serial plotter. This is where you're basically seeing your UV light hitting the photo transistor and then telling it to move a frame, take a picture, move a frame, take a picture. So here you can see the auto white balance and auto exposure. I'm kind of messing around with both. It'll display a picture. It's not a live view of the camera. It's the previous picture it takes. So kind of essentially the same, but I think the reason for that is it just works a lot better to do that. Again, yeah, so far it is night and day difference better than the Kodak reels. Obviously, it uses a better camera. It doesn't move based on the perforation with a perforation mechanical arm. It uses the rollers, so there is some movement based on the program, so you do have to stabilize this afterwards, which I will touch on how I do that and what I'm currently doing and the alternate versions. So let's get into a comparison. So here we have on the left hand side the Kodak reels, and on the right hand side the DIY scanner with Alt-Scan and After-Scan, which is a post-processing software developed by the same person who developed Alt-Scan. So this is Ektachrome 100D, shot a few months ago in my Minolta XL401. It's the first time shooting color reversal, and then this was my first time home processing color reversal in E6 chemistry. So shout out to the Naked Photographer and his channel. Helped tremendously with knowing what to do with the Bellini E6 kit. But yeah, so you can see right off the bat the white balance is quite a bit different. It does look a little bit sharper as well. But the biggest thing for me is the white balance. I do want to experiment with color negative film. That'll be future ambitions. I have some Vision 3 stock, a few rolls of that I've shot that I want to process at home and scan. So that'll be a whole different ballpark though with color negative. But yeah, you can see I'm still kind of figuring out the stabilization in After-Scan. This is mostly due to how my scanner captured a certain amount of frames and kind of looked a little wonky. But again, this is relatively new for me, so I'm sure I'm going to get some of the kinks figured out. But yeah, this was at the Michigan Renaissance Festival, so I thought it would be cool to capture something like this on film, especially Ektachrome. Jousting is pretty cool. It's kind of weird to think someone one day might watch this film on the actual film on a projector and be very confused about what year or century it is. But yeah, anyway, kind of go through the rest of it and see what it looks like. Okay, I'm going to go over After-Scan just a little bit. Nothing too definitive. This is developed by the same person who developed the Alt-Scan software. This is a post-processing tool. It will basically take all the images that you scanned and then compile them into a video, can do some stabilization, denoising, sharpen, kind of a slew of things. This is basically to avoid using something like DaVinci Resolve. I'm kind of going back and forth between using both till I figure things out a little bit better. I've only used this a few times. So yeah, I'm also re-recording the audio for this, so I'm going to try to match up with whatever I was trying to say earlier, but apparently the audio didn't work. So you have your source and your target. Your source is where your images come from, wherever you saved them. I've learned that you shouldn't pull directly from the flash drive. You should put them back onto your PC somewhere and then pull from there. For some reason, it didn't work too well pulling from the flash drive. And then your target's where you want them to save. Below that, you have either Super 8 or Regular 8. Pick which one based on what you have, obviously, and then you can either encode all the frames or only partially. And then below that is where you define your template, where the perforation holes are. I'm still figuring that out with the Regular 8. Super 8's really easy because you just drag it over the one square. And then below that, you have your stabilize and your crop area. So this is already pre-cropped because I had to do this a few times. It kept crashing on me. So luckily the developer's very hands-on and helpful, has a Discord channel. So I've been communicating with him back and forth to get things figured out. But so yeah, I cropped this in 4:3 aspect ratio. I didn't do any denoising or sharpening or anything like that. Check the box for video. And then basically your frames per second. This is Regular 8, which is 16. And then over here you have best quality, medium, fast. I tried best quality, but I got a lot of artifacting. So he told me to just go with fast and that there wasn't a huge difference. So I'm sticking with that right now until he gets that figured out or whatever. And then your resolution. You can go up to 4K. I'm doing 2K right now just because I didn't truly notice a huge difference, even though I scanned them in 4K. So yeah, other than that, once you get all set up, you hit start scan. I launched this in PowerShell since this is a Python program, so I kept it open so you can kind of see what happens. It uses OpenCV. This part freaked me out because I thought it was failing, but I guess this is normal. I'm not familiar with OpenCV or the program, but when you see a bunch of warnings go by and saying ignoring it, I thought it wasn't working. So you can see the frames jump around. That's all based on the actual scanned images. So if your scans weren't basically scanned or a picture taken of it straight on, it's not going to be able to stabilize properly. So that's the one kind of flaw so far with this versus the Kodak Reels, is the Kodak Reels uses an actual mechanical arm with the perforation and moves it, so it's always being moved in the exact same spot, versus this uses rollers and the UV LED to try to line it up, so it's not perfect. The mechanical arm probably would be better, but this also would be beneficial if you had any damaged film from perforations. You wouldn't have to worry about that. And then right here it says your video's done, and we're going to take a look at it. So same thing as earlier, Kodak Reels on the left and the DIY scanner on the right. You can see still having some stabilization issues that I'm working on. The white balance is quite a bit different. It's also a bit sharper. You can obviously see way more scratches because it's just a higher quality photo of each frame. Whether that's good or bad, I don't know. If it wasn't scratched film, obviously it wouldn't be a big deal. I also think the Kodak Reels probably created some scratches because my Ektachrome had a pretty large scratch in it that wasn't there originally when I inspected it before scanning. So anyway, this is what old film looks like, the difference. I still have a lot of experimenting to go, which includes my next project, which will be to process at home some Kodak Vision 3 color negative stock with ECN2 chemistry. I have quite a few rolls of that shot, recent one from Yakima Valley during hop harvest. And then, yeah, I got some super old Ektachrome that I experimented with just as black and white. But yeah, I'd like to keep shooting more. Here's some just kind of overview, a little darkroom setup with everything. But yeah, I think overall this is a fun project for anyone who wants to get into scanning and potentially processing their own Super 8. It's obviously not on the level of a professional lab. I don't have a laser graphics scanner or anything like that, or able to afford one, but I think this is fun for anyone who's into a DIY motion picture film. But yeah, hopefully soon I'll be able to process and scan some Kodak Vision 3 stock and upload that, and maybe show a little workflow of working with color negative stock with this scanner. But until then, thanks for watching. If you have any questions, feel free to ask and I'll try to answer. Thanks.